Hello everyone, I am Vidya Chatratmat, Assistant Professor from STJ Institute of Technology, Ranebennur. So in the previous video, we have discussed the different types of designing of the flexible pavement, that is CANAS method, and the design of flexible pavement by the McKeld method. So in this session, we are going to start with one of the important method of designing of flexible pavement. That is what the design of flexible pavement by this CBR method. So let us see how to design this flexible pavement by this California bearing ratio method. So now you can observe here, so some of the guidelines has been given by the IRC is nothing but Indian Road Congress has been given some of the guidelines for the designing of the flexible pavement. So I can discuss what are all the guidelines that has been given by this Indian Road Congress. So briefly I will explain. So what are all the design approaches we need to consider for the designing of a pavement as per the Indian Road Congress guidelines. So first what you have to do, the total thickness of the flexible pavement is calculated or designed by the CBR charts. So whatever the method I am going to explain in this video, it is what the designing of this flexible pavement by this CBR method. So after designing, usually, so this flexible pavement is represented by the elastic three-layer system. So means we are considering this flexible pavement as a three-layer system. So you can observe here at the first layer, which is comprises of dense bituminous mix as well as the bituminous concrete. That is, at the first layer what it is having, dense bituminous mix is there, and the bituminous concrete, it is at the top layer. So then it is the thickness has been considered a H1 and modulus of elasticity, as we know, which is having the different modulus of elasticity for each layer, that is, it is E1. So now again in the second layer, which is having the sub base course and the granular base, that is the sub base as well as the granular base are the layers which are situated in the second layer, and the thickness is H2, modulus of elasticity is E2. Similarly, the last layer is nothing but what, your prepared subgrade. Whatever the prepared subgrade is there, that is considered as a last layer. So after having all the thickness of these layers along with the different modulus of elasticity, then you are going to evaluate the strain in the critical location. So you will come across the two types of the strains. Horizontal strains you may observe at the bottom of the bituminous layer, and the vertical strain is at the top of the subgrade layer. So these strains is you need to calculate. So then higher magnitude of horizontal strain in the stiff bituminous layer, it will causes the fracture in the layer, and the higher magnitude of vertical strain at the top subgrade may causes the permanent deformation. So this is what the cause of the strain on the pavement. So in order to avoid these causes or the effect of the strains or stresses on this pavement, we need to design the pavement such that there should it should not be exceed the desirable limit. So whatever the total depth you are providing, it should not exceed the desirable limit. So like that you need to design this pavement. So this is what the general guidelines has been given by this Indian Road Congress. So let us see how to solve or how to design the pavement by this California bearing ratio method. So you can observe some of the design considerations has been explained here. So in order to design the pavement by CBR method, you need to you need to have these points, or you need to have these data for the designing of this pavement. So one is the subgrade value. What is the California bearing ratio value of a subgrade has been given in the problem itself, and the initial traffic at the time of construction. So initial traffic you need to consider, that is N. Design life, so means the pavement is designed for the how many years, it for the 10 years, 20 years, so that design life you need to consider. And the growth rate of a vehicle, so R you need to consider here, growth rate. And the vehicle damage factor VDF, vehicle damage factor. It is represented by VDF, that is in the formula F you have noted as a vehicle damage factor. And the lane distribution factors. So the lane distribution factor is also given by the as per the IRC recommendation. So these parameters we are required for the designing of the flexible pavement by this CBR method. So now you just look over this, the line distribution factor, the lane distribution factor. This is where as per the recommendation. You just observe here, there are different lane distribution factor is given for the different conditions. It has been listed from A to F. So you can refer in the Justo and Kana textbook from old edition as well as the new edition for more informations. So for undivided road, single lane, we are having the lane distribution factor is 1, and the undivided 2-lane carriageway D is equal to 0.5, and undivided 4-lane carriageway D is equal to 0.4. So like that we are having the lane distribution factor. In these three cases, whatever the traffic, that is total number of heavy vehicles along both the direction has been considered. Both the direction means what? You have so if there is a 2-lane, you have to consider the traffic on the both the direction. So then this D, that is lane distribution factor, has been provided. Similarly with for the different cases, it is divided in carriageway 2 lanes with the heavy vehicles, that is divided. Here undivided is there, it is divided is there. So like that there are different lane distribution factors are there. They may give the lane distribution factor in the problem itself. Otherwise you have to remember this lane distribution factors for the different lane conditions. So now this is what the exact procedure of the flexible pavement design by the CBR design charts. So just I will explain what is this charts, how you are going to use this chart in the designing of the pavement. So in the Indian Road Congress has given some guidelines for the designing of this flexible pavement, and they have presented the two design charts to determine the thickness of the flexible pavement. So and here you should care should be taken here. The subgrade soil with a value of traffic range or CSA value, that is cumulative number of standard axials. So that value range between 2 to 10% only you are considering this design. So now we will come across the two charts. Just I will explain in the chart itself. You can see here. So these are all the two charts what we are going to use for the designing of this flexible pavement. Clearly observe this chart. We are having the CSA value is nothing but what? CSA is nothing but cumulative number of standard axials. Is nothing but it is used to design the pavement. So it is going to tell us the number of commercial vehicles that would be occupied on the road at the end of the design life. So at the end of the design life, how many, that is the total traffic. So that is what the CSA, that is cumulative number of standard axials. So the cumulative number of standard axials has been given in the x-axis, and the total thickness of the pavement is given in the y-axis. And we are having the different design curves which is indicated the CBR value. The CBR value is varying from 2% to 10% here. 2% to 10% CBR values are there. So like that it has been given. This is what the graph what we are used for the designing of the flexible pavement. So here what is the main thing here? So this chart is nothing but 7.14 is the chart whenever we are using this cumulative number of standard axial value is lies between 1 to 10 MSA. So 1 to, if it is 1 to 10 MSA, then only we will use this chart. You are going to calculate what is the cumulative standard axials value. So based on this value, if it is 1 to 10 MSA is nothing but million standard axial. MSA indicates what? Million standard axial. So whenever it is 1 to 10 MSA, then only you can use this chart. So if this cumulative standard axial value is greater than 10, so that is if it is lies between 10 to 150, That is, then you can use this 7.15 chart. So since whatever the values we are obtaining, so after the increment of 30 cumulative number of standard axial, after this 30 value there is a gradual variation is there, so that so in this graph whatever the x-axis is there, this is what the log graph has been shown here, and the normal arithmetic graph has been shown in this y-axis. Similarly, x-axis is also showing the CSA values, cumulative standard axial values, and y-axis shows the thickness of the pavement here. Suppose if you are having any CSA value here, corresponding CBR value they will give. The corresponding value on the y-axis will be the your thickness of the pavement. So like that you have to design the pavement using this CBR chart. So that is only the explained here. That is the figure 7.1 is used for the moderate or a low vehicle. You should remember this one. So it is taken for the moderate or a low vehicle, and usually the 7.15 is used for the designing for the medium or very high volume of the vehicle. So for this purpose we are using this one. And one more thing is, if the cumulative standard axial value, if it is 1 to 10, then we can use the first graph. If it is 1 to 10 to 15, then we will use the 10 to 150, then we will use the second graph. Just I will highlight you, just observe here. So this is what, if it is 1 to 10, then we can use this value, and if it is 10 to 150, then we will use this figure. So this is what the description has been given for the particular graph. So this is regarding the graph. So then after find outing the pavement thickness, suppose if you are having the some pavement thickness 300 mm, 500 mm, so like that you have obtained the sum of the pavement thickness. So then you need to divide that entire thickness of the pavement into the number of layers, because you are designing the flexible pavement, therefore you need to divide that into the number of layers. So how you are going to divide that one? So what is the thickness of the each layer? So that is decided by the as per the Indian Road Congress guidelines. So you can observe here, these are the some tabular column has been given for this designing purpose, for the fixing of the whatever the thickness of the different layers in the flexible pavement. So you can observe here. So just observe the title carefully. The pavement design with the recommended component layers, cumulative traffic range. So cumulative traffic range is nothing but what here? So it is CSA value, that is cumulative number of standard axial value. If it is 1 to 10, MSA again same million standard axial. So then you can use this chart. So this is what the one thing here. Also we are having the two different tables as per the IRC guidelines, table 7.3 as well as table 7.4. You may get these tables in your Jasto and Kanna textbook. So you just observe here, if it is the cumulative standard axial values, if it is 1 to 10, then you can refer this table. The CBR value is given, cumulative standard axial values are given. So you can observe here, it is 1 to 10 is a cumulative axial cumulative number of standard axials are 1 to 10 here. So for each CBR value, 3 is there, 4 is there, 6, 8, like that we are having the for the different CBR values we are having, and the total thickness. So if it is so then the total thickness is what that has been given. So suppose if your the CBR value is 4 and your cumulative standard axial value is 3, then you can refer these column. Clear? You can refer these column for the different thickness. So what are all the different types of surfaces or layers has been provided in this pavement is nothing but granular sub-base course, that is GSB, granular sub-base course, and the granular base course, binder course, surface course. The thickness of respective layers has been described here. From this you need to take the values. Clear? So this is what the CBR value, and this is what the cumulative number of standard axial values. And if it is the cumulative standard axial values is 1 to 10, then only you can use this chart. Otherwise you have to move for the other chart. That is, if CSA value is 10 to 150, then you can use these table for the distribution of the thickness of the different layers. So the different layers comprises of what? Granular subbase, granular base, dense bituminous macadam, and the bituminous concrete surfacing. So these are all the different layers you need to provide after the designing. And the total thickness is given, CBR value is there, CSA value is there. So corresponding you need to find out. So this is what the complete procedure how to design this flexible pavement. So what are all the parameters we are using for the designing of this flexible pavement. So I will just recall it once. So first what we need these design parameters. So the for the lane distribution factor, the IRC recommendation is there. Otherwise you have to remember these values for the 2-lane traffic, 4-lane traffic, divided and undivided carriageways. We're having the different values. So now for the flexible pavement, we are having the two charts based on what? Cumulative standard axial values. So if the cumulative standard axial values is between 1 to 10, and if it is between 10 to 150, then we are having the two charts to find out the thickness. Again, x-axis it is having the CSA value, y-axis we are having the thickness. So like that, some tables are there in order to divide the, or in order to provide the particular thickness for the different layers of a whatever the pavement layers. We will use this tabular columns prescribed by this Indian Road Congress. Again, it is, if it is 1 to 10, we will use 7.3. If it is 10 to 150, that is cumulative standard axial value, we will use the table number 7.4. This is what the brief procedure of designing of the pavement by the CBR method, the complete procedure. So let us see the problem on this.